Alright, so I hope you got that formula down. We're going to try to practice with it, and I'll show you where all these pieces kind of come from. Alright, so T and H can be a little confusing, so let's go with that. Alright, so the half-life of carbon-11, that's an atom. Carbon-11 is an atom. Don't worry about the 11, it's just a name. Okay, there's carbon-14, carbon-12, don't worry about it. Carbon-11 is just a name. The half-life is 20 minutes. Well, that's helpful. That means H is going to be 20, oops, you can't see that. H is going to be 20 minutes. Now keep track of your units. That's going to be very helpful. Fill in the table to find the amount of carbon-11 left after 3 half-life cycles. Alright, so because they don't tell you an amount, you can start with any number you'd like. I typically start with 1, but you can start with 10, 100, you can start with 50, but 1 is kind of an easy number to start with. Alright, so number of half-life cycles. So if there's 1 half-life cycle, or 0 half-life cycles, okay, and we just start with 1, we start with 1 half-life cycle. After 1 half-life, we're going to half this, okay? 2 half-life cycles, we're going to half this number now. So 1/2 of a half is a fourth, okay? After 3 half-life cycles, we're going to half that fourth, and it's going to be 1/8, okay? Let's say you don't like that. Let's say you want to do a different number, because by all means, you don't like the fractions. So let's say you started with 100. Well, half of 100 is 50. Half of 50 is 25. Half of 25 is 12.5. Okay? So that's how the half-life works. It's just half every time. So now we're going to write an equation to describe a half-life. So the half-life of radioactive substance is 2 days. Alright, so H is going to be our 2 days. Alright? There are currently 150 grams. That's our initial value, or A naught, or initial value. Okay, so write an explicit equation. Well, I know A is what we're going to have left over. A naught is our initial value. 1/2 is our rate that's going down. T is time. H is half-life. So let's substitute these in. A is, the initial value is 150 grams. 1/2 is my rate. T, I don't know how many half-lives there's been, so we're just going to leave that. And then the number of days is 2. Alright. How many grams will remain in 8 days? Sorry about the bell. How many grams will remain in 8 days? So this is our equation we just substituted, and it's the same thing. We're defining our variables, which we did, then we substitute them in, and then we solve. So here we go. I know 8 days, they give that to you. The half-life is 2 days, so that's why that's H. The total days we're using is going to be T, so T is 8 days. Be careful. If this were in hours, we would have to convert one of the two numbers into that unit. Okay? So, and you'll probably see that down the line. Alright, so this is A equals 150 times 1/2, the 8 divided by 2 power, and if you simplify that, it's 150 1/2 to the 4th power. And if you type that in your calculator, make sure you use the caret symbol. So 150 times 1 divided by 2 raised to the 4th power. So that caret symbol there is important. And your fraction just goes in parentheses. So it means we'll have 9.375 grams of our substance left after 8 days. 9.375 grams. Okay? And that is our formula. Okay? So, good luck. I hope that helps. So, like everything else, first you want to define your variables. Second, you're going to substitute. And then third, simplify and solve. Okay? Since I got about another 30 seconds, we can try another one. So HD197, that is a name. Okay? Be careful about confusing those numbers. But typically, Hg-197 or carbon-11, that number belongs to those words and they are combined, they are a name. Alright, so Hg-197 is used in kidney scans and has a half-life of 64.128 hours. Alright, write an exponential function for a 12 milligram sample. So that would be our initial value, and you know what? This says our half-life is 64.128 hours, so that is our H, and this we don't need, it's just a name. So that means A equals A naught, which is 12. 1/2 is our rate, always, for half-life. Hours, well, I don't have the time, but I do have the half-life, so 64.128. Okay, and then it tells us 72 hours. Okay, well, now we're going to substitute that in. 12, 1/2, 72 hours is now our time. 72, 64.128. You can substitute that whole thing in your calculator. It looks like this. Looks like this. Alright, 12 times 1/2 raised. Now because this is a fraction for an exponent, we're going to put it in parentheses. 72 divided by 64.128. Close your parentheses, hit enter, and it tells you you will have 5.5 grams remaining, or 5.51 will just be a little more specific, milligrams remaining after 72 hours. Okay? Alright, good luck.